Hello and welcome to a new tutorial. So this is as a short version of the tutorial. At the last minute I decided to not only upload one long tutorial but upload two versions of the tutorial, one which has all the details and every single parameter and every single value. This is probably over than 30 minutes, and the other version, which is this one, it's fairly small, to be honest. So this is explaining the process, what I made, what was the tricks, what the technique is, and let it for you. If you need more details, if there are things that you cannot do, can't figure out, you can check the long tutorial in the description below or up there. Anyways, after watching a Blake's Tale last gameplay, been announced last week, I guess, maybe the week before, I can't remember, I really got impressed with the rats. I loved those rats and I wanted to replicate them, I wanted to make them, and after making them I wanted to share how this was possible. I made several things similar to those rats before with Unreal and Cascade, but I wanted to do this with Niagara. Niagara is a new thing, Niagara is a promising thing, and I wanted to do it with this. So the whole thing started very easy. I searched on the internet for some rats. I found a free 3D model for a rat. It doesn't have textures, it doesn't have bones or animations or anything, which I'm okay with that. So I got this mesh. You can if you have better mesh, if you can make your own mesh, it's totally fine. I got this mesh and then I moved it to 3D Studio Max, and there I start using cat, which is character animation toolkit, to do rigging. I love this cat because it gives me the opportunity to create a functional rig for any creature, even humanoid, start humanoid to centipede or dragon or whatever. So creating any rig very quickly, and then you can have animation and walk or run cycles very quickly. So this was my process. I use 3D Max for that reason. Another reason that I use Max for is it's heavily integrated into Unreal's pipeline for the Vertex Animation. Regardless, you are going to do Vertex Animation or Pivot Painter or Pivot or whatever, there are lots of Max scripts that are very handy. If you are going to do this with Blender or Maya or anything else, you probably will either do your own scripts or you will need to purchase some scripts from somewhere on the internet. Anyways, after doing the animation, I used Vertex Animation tools in Unreal Engine to export those animations to Unreal, and this gave me two images, which is an EXR and PMP, one for the normal and one for the vertex positions. If you don't know what this technique is, you can check my previous video about Houdini and Unreal for fluid simulation. This was using a similar technique. Anyways, also I have exported the mesh that I used, just the mesh. I don't need any animations in this mesh, so I exported the mesh as an FBX. And then when we go to Unreal, first thing first, I'm going to use Niagara, so I needed to enable Niagara and restart as always. And after enabling Niagara, I imported the mesh, of course, and imported the two textures, created a material, very simple material. The material can take a color, it has some parameters that you can set. Again, this is just for the sake of modularity, but the most important part in this material is the world position offset that is driven by the morph, the Vertex Animation morph node that comes with Unreal. But again, I made the material with you can change the color in the material instance, you can change the roughness, specular, the metallic, and those things. And later on, after finishing the project, I made the emission color because I'm going to use the same material for eyes. But anyways, the most important part for this material is to use the Vertex Animation morph node. Assigns the two textures that's being exported from 3D Max to this node, and enable in this material domain, enable the UVs, because the UV usually have one UV. You can enable 4 UVs because the Vertex Animation node needs the UV number 2 and UV number 3. And with this material, you can have, by assigning this material to a rat, just a static mesh rat, you'll have this rat doing the exact same animations that we have in 3D Studio Max. Now with Niagara creating only one system and one Niagara emitter, I send this emitter to the system and start adding a bunch of modules. Those modules are for like the particle lifetime, the life cycle of each particle, the update, the spawn, the rate, and I add also a rotation, like initial rotation for the mesh. I add a render module that is mesh renderer, because you have you have ribbon, you have sprite, you have many things, but we need the mesh, and assign the rat mesh that we exported from 3D Max, which is, by the way, using the new material we created, and assign this mesh to the renderer, and boom, we have this Niagara emitter. The emitter, I used a box location. You can use a sphere location, you can use whatever location, but I needed those rats to look like a group of rats on the ground, so I made a box location, and then I expand this location to be as huge as I wanted it to be, and yeah, disable the Z value for the box, so I make sure that it looks like a rectangle, not actually a box, and this rectangle have no height, it's just X and Y, there is no Z value, and this give me those rats. But those rats doesn't have any behaviors. They don't, like, they just running on their place. They don't do anything impressive. And this is take me to another point where I start adding force. I added a point attraction force, and with a point attraction force, this is what it does. It actually, you define a point for the particles, and this point will either attract particles or push particles. The only issue is this, that it is working as a sphere, which means it's going to grab or push particles in a sphere shape, and this means they will be moving on a z-axis, and this is not desirable. Those are rats. So I then start using one of the benefits coming with Niagara, that's the ability to create and craft new modules, your own custom modules. But instead of creating a module from scratch, I did copy one of the old modules, and they are very easily can be found within, if you enable like in your content browser, if you enable the engine content, you can find them. So I copy one of those, which is actually the point attraction force, and modified this. I didn't use any of the Z values, I use only the X and Y values for the force, and keep Z value for 0. And then I later multiplied this with the direction of the particle. I got the direction of each particle and multiply this with the force and use it. Now, this attraction point, it's, as the name implies, it's called point attraction force. Now there is attraction. We define the force, we define the value, but the attraction itself happens on a point, and we need this point to please a player. So Niagara have one other impressive feature, that you are able to create parameters or variables, and you can control these variables from anywhere within your project. I've created a parameter I called attractor position, and you can see this is called user, because it is something you created. It's not related to the system, it's not related to the emitter, it is something custom made. And then I use this for the attractor behavior, or the attractor module, or the point attraction force module. And this means this variable will be the point where the attraction will happen. Attraction means grabbing or pushing, it doesn't matter. And then from the level blueprint, I start getting, in every tick, in every frame, I get the player location, and then I use this value of the player location as the attractor point. So I assign this value to the rat's attractor point. So you can see it's all connected together, that I use a player, with the player move, we get its location, we use its location to pass it to the Niagara emitter or Niagara system, to this new variable that we created, and this new variable is used as a attractor point within a module that is point attraction force, and it uses this force strength and the force size to apply for the particles, which is the rats. So this is how the whole thing is working. At the end, you can see there are some rats are running side by side or running backwards. They're doing like the moon dance from Michael Jackson, but this is totally fine. We can paste this on the player direction itself. And this would probably need, we create another variable, user custom variable within Niagara system, and this variable gets the player direction, and then they react based on the player direction. But again, this is the entire workflow, and this is how I made it, and this is how you can have thousands of rats running from the player like a Plague's Tale. And by the way, this is impressive game, interesting game. I'm really looking forward to play this game. If you are interested in more details, you can check the long video in the description below. Until next tutorial, see you. Bye.